So I'm just going to talk about some of the things folks have touched on and do a little more detail on that with getting started and what steps are involved in that. You need the printout of your grill to be actual size. If you have the printout, you're going to need to make sure that you enlarge that 100%. The other things that are available on the website, I find you can print those out, cut them, paste them, just like, and tape them. But if you want a pretty clean copy, I download it onto a thumb drive or even email it to myself, and I can take it to any print shop. I have one right here. There's a FedEx that they used to call Kinko's, and you can print it out there on one sheet of paper. Your other option is to take the summer 22 version of the Hammer's Blow and take that to a copy shop and print that out as a copy. So you have a couple options, but the bottom line is you're going to need an actual size for a life-size paper version of that grill. So there you go. I'm going to talk about a method that involves stuff hopefully a lot of people have on hand and get it to a rusty tin plate. And bottom line is you need something that won't burn when it's placed near the hot metal. And you'd think that'd be obvious, but when I was doing my grill, I still have my burnt version of my paper before I figured this bit out that I needed to put it on a rusty tin plate. If your tin plate isn't rusty, there won't be any teeth for this method to work. We're going to be using chalk to transfer that. So it has to be rusty. And if you don't have a rusty tin plate, you can rust it easily by taking water. I add a little vinegar to that, just a splash, don't overthink it too much. I suppose you could even spray straight vinegar on this and it'll rust overnight, or at least it did here in dry Sacramento. If you're in a more humid location, it might just rust for you overnight, or maybe you don't even get to have any non-rusted tin plate. I probably picked up that vernacular from Mark. He always says rusty tin plate. So just a thin piece of sheet metal, like 16 gauge is usually what I use. That is what I'm talking about. And it is steel, not galvanized. You want something that's going to rust. Once it's rusted, make sure there's no extra debris. So brush off that debris, any loose bits, without taking away the rust. So fine line. If you don't want to use this method, there are other options, and I'm sure there's more that I'm about to show you, but this is a little collection of photos that I have from different methods people have tried. Carol DeMainton actually has an engraver, and I think she made a work of art here with her Level II Grille quadrant. You could do that as well, but she engraved the copy of the grill onto that. John Barron I'm pretty sure he freehands this onto a piece of particle board, and he's got some mad artist skills. I don't know that all of us have that, and he's very precise. You could probably use a version of this method that allows you to transfer the paper to the particle board, but he likes the particle board. He then erases that and uses it again for another project. Frank showed us the center punch line outline version of transference, and so you could do that as well. And then most recently, Patrick, who is in my coaching group, showed me this, and this is just a screenshot of what he held up to the camera. He didn't want to rust his tin plate. He liked it nice and shiny still, so he had on hand some Dicam layout fluid and used that, and then used the method that I'm going to walk us through right now. So if you have other methods, I'd love to see photos of those and hear descriptions of what else folks do to transfer a schematic to whatever they're going to hold their metal up to while they're putting their project together. So the supplies, we're going to transfer this to this rusty tin plate by putting chalk on the back of this paper or brown paper bag. I have this heavy construction paper. The heavy construction paper in between the printed version of your grill and the tin plate does make a little softer landing for your pen. So I do tend to put the construction paper in between there, and the chalk goes on the back of either construction paper or the back of your grill. And then all of that can be secured with pins, push pins, thumbtacks, or tape to your grill. I have holes in the corner of my tin plate. Now I want to say steel plate, to hold that in place. What makes that nice is once it's pinned in all four corners and I get to tracing, I can pick up a corner. I can pick up one thumbtack and look underneath and make sure everything is transferring nicely. Tape, you can do that too. It just gets a little messier and I'm a little more leery of picking that up once I get going. If you pick it up, once you get going, it's hard to put it, well, I'd say it was impossible to put it right back in the same place. So the thumbtacks or the tape come in handy for that. I'm going to trace with a colored pencil, and then I'm going to go over my chalk outline with some sort of more permanent marker. This is an Inksol that writes on metal, and this is a Silver Streak Welder's silver pencil. So here's a couple photos just depicting that process. I'm chalking up the back of my heavy construction paper. I'll even rub that in a little with my fingers, but I don't like to get a nice thick coat. And then that is going to go down first up against the tin plate, and then the drawing over that. If you just chalk up your drawing, obviously you don't need that in the middle. And then I'm going to thumbtack all four corners and have that all nice and flat and secure. Then I'm going to start tracing it out with a colored pen. If you don't use a colored pen, like let's say you use black, it's very difficult to see where you haven't been. You could pick up one thumbtack and take a peek and look and see if there's places you missed. But I find that the colored pen really helps showcase where I haven't traced any section of the grill, and make sure you get the frame and everything included. When you lift all that up, you're going to have a faint chalk outline, and you'll want to go over that with something a little more substantial that won't be prone to smudging. While you're doing that, make sure you start in the corner of the plate that accommodates whatever hand you are. Like I'm left-handed, so I needed to start down in the left-hand corner so that as I progressed, I'm not smudging out that chalk. That chalk outline is very fragile. So as I went along this, I made sure that I had already traced out the part my hand would be resting on, or try not to rest your hand, but just a helpful hint there. So once you have everything traced out, you're ready. You now have something that you can put your scrolls up against as you are bending these into position and making sure that you have conformed to the forging 2 dimension. So let's move on to measurements. Measurements need to be made off of the copy you end up with. If you enlarge this, or if you downloaded it off the website, or you took it to a copy shop, no matter what you've done, there's a chance, maybe a slight chance, but there's a chance that the final measurements aren't exactly what's called out in this grill. The most important thing is that your grill conforms to your version of the printout. So make sure, and it should be within close dimension to this, but if it's not, make sure that you're using the dimensions on your plate or your printout. You're going to start with the frame, and Frank's going to go over a little bit of that. You're going to start with your corners, and your tenon is on the long side and your mortise is on the short side. These are two identical pieces, except for the method of making the corners. One's sharp, one has that more radius inside edge. To get the right measurement for this, I know that the total length from outside to outside is that 12.5. And I need to account for that 3/8 bar that's going to be in the middle there or added on. And I'm going to subtract the total. I'm going to subtract that from the total length. That gets me to 12.1/8. Then, and this is very important, you need to do a test piece for your tenon using the size material you're going to use. That test piece tells you how much you gain or lose when you make a tenon. I tend to lose 1/8 of an inch, so I'm going to add on 1/8 of an inch before I start making my tenon. I'll have made my square corner already, and then I'm going to measure either from the center line or from that outside corner to get to exactly where I need to start that tenon using this math formula. If I start from that inside corner, I need to subtract. Well, actually, I'm going to just say I'm going to go from the outside to where I'm going to start that shoulder for the tenon. And then keep in mind that the mortise is on the short side, and then you'll need to measure to get to where exactly to place that. I find that easier once I have both pieces made, and then I can line them up together, making sure that they fit together, and then it's easy for me to mark out by drawing a line on either side of my tenon as I place it over the edge of that bar. Russ pointed out in a presentation or two ago that math kind of buzzes him out. In fact, I remember all kinds of numbers and everything on his slide. If you have that same reaction and fractions give you a headache, there are apps to calculate fractions. Like, you don't have to do it longhand or in your head or anything. And the one of my students pointed out to me was this I fraction. I found when I went to look for this one, there's lots of them, but they make it super simple to calculate fractions. Your next order of business is to make your scrolls, and the conundrum is going to be, how much parent stock do you need to cut to get these S scrolls to perfectly match and fit in your frame? We can measure all of this and get a total length of each scroll, but that doesn't account for making these finials. You've got one on each end, and they're each going to take less parent stock than it is to have the total length of them, because you're going to do stuff to them. So make reference marks that you then stick with. These reference mark becomes your standard, and I have reference marks here because it's a straightaway. That's easy. I can just put my rule up against that. I can measure how much that is. These scrolly bits, these turn bits, I could measure those too, but it's difficult to know where to measure. The inside has a shorter distance to travel and is actually a shorter measurement than the outside, which has a longer distance to travel and therefore is longer. The only measurement, and Becky was pointing this out in her presentation, the only measurement that stays true to that parent stock is this center line. Call that a neutral axis. Make sure you use that when you're measuring the curved bits. Then this mark, this reference mark, is where it seems to me that the taper is ending for this scroll. And I also just find it handy that this is where it butts up against the frame. You may want to put this reference mark somewhere else, and that's perfectly fine. There's no, you must put it here kind of rule. Or maybe you want to make your grill a little fancier by bringing a taper, maybe even way out to here. I would just make sure that your reference marks corresponds with where that taper ends, because that's going to be the tricky part to measure. So your reference marks become your own. We're now ready to measure the rounded areas, and I find it easiest to just use dividers, and I march that out to every 1/2 inch. And you could use less, like if you wanted to march out every 1/4 inch, you could. I think that's probably a little too fussy for the kind of the gradual curves we've got going on here, but I find any more, I'm not going to stick to the true curve. So set your divider out to every 1/2 inch, and then just start marching that along to the center of the scrolls. And at each reference mark, I stop and I mark it on my paper. And then at each reference mark, I start a new measurement. You could just march this along and count that in your head. I find that difficult. I find it easier to mark each mark as I go. My dividers are sharp enough that they leave a little punch mark there. And sometimes I color those on my piece of paper so that I can just count them later to double check my measurements. So before you cut your stock, you're going to want to practice those finial pieces. Practice them until you are confident that you know exactly how much, or that they're consistent, that you're making your finials consistently the same. And then start that scroll back to that reference mark. Then you're going to take a piece of bar, mark it at about 10 inches or so. You should probably be working with long bars anyway, so that you don't have to use tongs. Make your finial scroll to your reference mark, and then the 10-inch mark you made on your parent stock, minus the amount left on your parent stock, is the amount you used for that finial. Write that down on your paper, and then you know how much material you need for this finial. You've measured out the rest. You know how much parent stock you need for this finial. You now know how much parent stock you need. And the only other thing I want to caution you is that whatever scroll you start with, that's the freebie, right? Like you get to make that, and you get to bring this around to whatever your reference mark is, but it's the next one that you have to cut that bar to the exact measurement. So some of these are harder to do. Some of these are harder to do than others. So choose wisely, because that first one is a freebie. Okay. That's all I have.
Now comes the practical part, putting the frame together and making the scrolls, the 2-ended S scrolls, to size, and assembling the whole thing into the grill. Here's my plate, and it's not rusty, it's shiny. And because it's shiny, the chalk wouldn't show up. And so I used a black felt pen to make the outline visible. You may remember that my method was to use a center punch. I like the center punch method because if I burn my felt pen off, then I can reapply it because I can still see the little dimples from the center punch. I assume that by now we have 2 L-shaped pieces made for the frame with the 2 slightly different corners. And I'm in the process of putting these together to be a frame. And before I go and get the rivets hammered down, we better check for accuracy. We know that the long leg should be 12 1/8 inch long to start the tenon. We know that the tenon should be 3/8 plus 1.5 times the thickness of the tenon my tenon is 5/16. That makes about 7/8. It's a little less, but 7/8 is a good measure for that. The short leg, I center it to the center of the hole, and that would makes the short leg 9 5/6. If the corners are really square, I check for tilts in the legs, and I check for bulges. I show you in a little more detail what I mean with this. The length, 12 1/8 to here. The tenon, I marked here 7/8. I need to cut that. Also, I need to straighten the tenon here. Every correction I do at this stage saves time when I'm trying to do it later. One of my corners wasn't square. Actually, it was square in the corner, but then there was a bend in the middle here. So I have to take that out. Next, I check if there is a tilt, and you see this leg, it's looking down from the end to the other leg. It is slightly tilted. It's a little toward the outside and the bottom. That's easy to repair at this stage. I also had in one of the holes that I had punched, I had a bulge on the inside. So I filed that out. And then I was ready to put the two pieces together. Put that together and put it on my sheet metal drawing. Last check, and everything was fine. If I would have seen that one leg is too short or too long, I could have corrected that. A short leg, I could have just hammered a little bit in the middle and easily would have gained 1/8 or something. If the leg with the tenon is too long, you can upset the shoulder a little bit. If the leg with a hole is too long, then that's a little more difficult. You probably could heat it in the middle and shorten that a little bit. It shouldn't be more than 1/8 off anyway, if you followed all the steps that we've taught before. Now comes the moment that you need to decide how you want to support your piece when you rivet the tenons. One thing I use a lot, as I showed here in the right corner, is I have a vise on the edge of my table, and I can slide my anvil towards it, and I can clamp it here and have the anvil support on the other side, and can hammer this down without any marring on this side. I can do the same thing on the table too, if it's light stock like what we have here. That works pretty good. Some people like to screw the tenons tight that they're not working on while they work on the other side to fix the frame. One thing to have in mind, and this picture is not exactly right, you shouldn't do the threads all the way down to where you put your tenon or your rivet against, because then you get cold shuts. So you thread not all the way down and then use some washers so you have some clean stuff in the bottom. What I decided to do, since this frame with just 2 tenons is pretty stable without clinching the rivets, I just did this freehand. And I show you a little video here. I heated up the corner of the frame. Usually when I do tenon, I use a torch, but I thought not everybody might have a torch and this. So I did it this way. On my first rivet, you see here, I'm kind of very careful. You can also see, let me stop this here. Oops. That it seems like, and it doesn't just seem like it is, I tend, and that's my personal habit, to pull the tenon towards me. And I hammered from the left side here, and the whole thing moved over. So I went around to correct, and I went around a couple times until I finally got this this rivet all the way down. You see now it's moving to the right. I go again to the other side, and finally I have it. I like the method with a torch better, because then just the rivet is hot, and there's no danger that I distort the frame while I'm riveting. Okay, this is the first rivet, almost done. Next step then is I look if this whole thing is still in one plane, and it was not. So better correct that now than before you finish the second rivet. I tried with a slight tap and didn't do much good. And I tried again and gave it a bigger whack, and then it was flat. For the second rivet, I got a little braver. Now the whole thing was pretty stable already, so it didn't take that long to clean it down. Try to avoid to make more frame pieces. So the first rivet, I was very, very careful. There we are. And it is still flat, almost. Okay, now we have a frame, and we need to make the scrolls to fit. Victoria just showed us a couple methods on how to do this measurement. This is the way I chose to do it. I just used one reference point. I call it the halfway point here. It's in the middle of that straight section and halfway down the grill. And for all the different scrolls, while I made my test scrolls, I have measured how much material it takes from here all the way around to the tip. And that's the number here. For the ribbon scroll was 14 3/4, for the snap 14 1/2, and for the other two 15. But that's not all I need. I need more information. The end is tapered, and the amount of parent stock I need will depend on how much taper I give to my finial. My taper, I tried to make about 3.5 inches long. That's where these numbers came from. And for the ribbon, I had a growth of material of 1 1.1 inches by the time I was finished with my taper. For the snap, it was just 1/2 inch. And the half penny, 1 inch, the bevel plus 5/8. So if I do a scroll and I want to make it to size, and I want to use these total stock numbers, I need to make sure that when I start with a taper, that I taper until I reach 1 1/8 and then stop there. Otherwise, the second number is not correct anymore. Best thing to do this is pick the two scrolls that are more difficult for you to make to size or to make at all. Finish them with enough material. You saw it takes about 15 inches per scroll, so you start maybe with 32 inches, so you're on the safe side. make your first scroll, you put it on, then you measure 14 3/4 here to here, cut it to length, and produce the second end. Same, of course, for the other scroll. I picked the beveled and the snub end to go first. Here is another thing that I learned the hard way. I did it wrong first. When you make your scroll, one important thing, if you want to make it to size, is the direction that tip points. I marked that here on my scroll jig. It points. If I make this pointing further to the left, I will use more stock. If it's more to the right, I will use less stock. So to make it the same every time, it doesn't really matter at the end where it points, but it needs to be always the same direction. Otherwise, you get different length. I made the second end here with a scroll jig. And if you look here, this points maybe this direction that I'm showing here. And the drawing shows this direction. So after it was done, it didn't fit. I mean, it wasn't a big deal, of course. This could be corrected, and I'll show you in a minute how this is corrected. I just need to scroll this in a little further until this tip points straight up, and then it will fit. So I start from the middle here. It's the opposite way than when you make a scroll, and correct things. First, I heated this piece up, took my bending fork about here, pushed this in. This led me to this version here. So it was in one heat, I had it done until this contact point. My next problem was here. So I went on and worked on that point. Heated it up. All this is done hot. Took two scrolling forks while the piece was on my plan and got this straightened out. So I got kind of a good fit here. I was still a little bit off here, but I didn't worry at this stage about that. I went to about 3/16, within 3/16 of the drawing, hot, and then corrected the remaining after I had put it into the frame. If you put it into the frame, it will not be exactly the same than your plan, because your frame will be maybe very slightly different. So it doesn't make any sense to be too correct in this stage. You might have to correct in the next step anyway. So the second scroll, same way, make it to fit within 3/16 or a quarter. Don't nail me down. You see, this is not exactly to the plan here. It's a slight difference here. It's a slight difference here. Don't worry about that. You put the two things in the frame. And at this stage, that's what I prefer to do. I go on and fit those cold. That gives me a little more freedom of doing things without heating them up in between and then making sure that I don't burn my fingers. Here's how I do that. I use my scrolling fork or the little U-shaped fork in the vise. And when I bend cold, I need to make sure that I have a long section. Say I have the fork here and I pull on this end. If this radius is to be widened, I pull on the very end and I do very little at a time. It flexes when it's cold, but then at a certain stage, you feel that it's giving, and do very little only. If you try to jerk it too much, you will produce kinks. It's much easier cold to produce kinks than it is hot. If it happens, you can use the hammer, like have a scrolling jig here, fork, and hammer the kink out. That works, but again, be very careful. After you're done with this, you should look, not if it's exactly to the plan. We are now working to the frame, not to the plan anymore. It looks smooth. All the curves should be smooth and round. Visually, it should look symmetrical, and the center line should be about in the center. And in my case, the fit was good enough that it would stay in there without any rivets. Now I needed to decide how I fix it to the frame. And what I decided is I put a screw in here and here where it's yellow, and a rivet, and rivets on the other side. For drilling, for the screws or the rivets, you need to mark exactly the center of your curve where it touches the frame. If you're off to one side, that will jerk the scroll to the left or to the right. So the better you hit the center, the better it will go. It helps if you have a white background and look from exactly above, and then you can see the center better. You mark the hole on the frame. This is for the screws. Drill the hole in the frame, then put the scroll back in, mark the scroll, and drill the second hole, smaller hole for the tap size. I used number 10 screws. They're about 3/16, and I think the tap side was 5/32 or something, but you can look that up in the table. For the rivets, you can drill both pieces at the same time. I use a clamp to make sure that the scroll stays centered while I'm drilling. This is what it looks at the end. This is the two rivets from the top, and of course the tenon rivet. My screws are countersunk. Just had these zinc-plated ones, so I probably have to remove those and get some steel-only screws that don't have coating. On the inside, it's almost invisible. I cut the screw off that it's flush on the inside too. One thing that easily happens is not so much with screws, but with rivets. When you rivet, and I did my rivets cold here, that didn't help. You put some force on the whole system, so my scrolls got out of plane doing that. I could still flex them in where they belonged, but they wouldn't stay there. You could fix those in the step when you put the collar on, but you can also fix them before. The way I like to do this is I force them in with my hands. It doesn't take much force, and then clamp it in place, and then heat up the middle piece here just to relieve the stress. And then after that, it's usually you have a perfect fit. And what you end up with is the scrolls all in place, and the only thing that's left to do here is to put the collars on.